All right, so we're still dealing with probability and odds, so we're going to do a couple more examples. Right, so we looked at probability, we looked at converting odds to probability, but now, right, it's very similar. Right, we can convert probability to odds. Right, and the way we do that is if we're given, right, we remember kind of our definition of probability, right, is the number of outcomes in favor of A happening over the total possible number of outcomes. So if we want to find, if we're given a probability and we want to find the odds, right? So the odds in favor of A, that means we'd have the total number of ways that A can happen and the total number of ways that A cannot happen. So it'd be total minus A. Right, and then the odds against A happening, again, we just switch these two. So odds against A happening, we have that number first. So it's total minus A, and then the number of ways that A can happen. Right, so let's do a quick example here. So we have the probability of a plane crashing is estimated to be 1 in 11 million. So we want to state the odds of a plane crashing, right? So we have, right, the odds of a plane crashing, right? So our first number should be the number of ways that a plane can crash, right? Well, that's 1. Right, because again, this is the outcomes in favor of A happening, or of our event. Our event is if the plane crashes, and that's 1 in a million. So it would be 1 here, and then this would be total, right? So our total is 11 million. So it would be 11 million minus 1. Right, and then just move down here. So then it would be 1 in 10 million 999,000. Right, so that was this one here, odds in favor. So now if we want to state the odds against a plane crashing, well, we know that if this is the odds of a plane crashing and we want the odds against a plane crashing, we know we just switch the two. Right, so we know what the answer should be, but if we didn't, if we were asked to do this one first, right, so we would have total minus the number of ways a plane can crash, which is 1, and then the odds would be, right, the total number of ways that a plane can crash. Right, so this would be 11 million minus 1 to 1. So again, we're just switching these. This is the odds against a plane crashing. Any questions in this first example? All right, for the second one, state the probability, the probability of a student passing the probability unit test is, so passing is 95%. And we want to state the odds of a student passing. Right, so we're given the probability as 95%, but we want it in its fraction form, right? The fraction form is the most useful form, right? So we're given the probability as a percent. So to convert to a fraction, right, what you can do is, so we know this is 95 over 100, right? So a percentage, to convert from percent to a fraction, you just write what the percent is, and it's always over 100, right? So if we have, let's say, X percent, we have an X percent, and we want to convert to a fraction, it's always X, that number, whatever X is, over 100. This is for probability, and this X can only be between, right, between 0 and, oh, run out of room, 100, because we're dealing with probability. So that's how we convert from percent to a fraction. So now we have the fraction form. So now we can state the odds of a student passing. We can use our formula up here. So the odds of a student passing. Well, they pass 95 out of 100 times, right? So the odds of them passing, right? 95 times out of 100 they pass. And then we would have the total, which is 100, right? So the total in this case, right, we get from the fraction there. So minus 95. So the odds would be 95 to 5. Well, this is page 21. So we want to state the probability against a student passing. So now we're asking for a probability against a student passing. Right, so we want the probability of not passing. Right, again, that's kind of that line above whatever that word is or letter is, just means not passing or not a pass. Right, so this is the number of ways that they don't pass, right? So that against passing is right, number of ways they don't pass over total, and that is 5 over 100. Right, and we can get that from here as well. We know that this is pass, and this number means don't pass. And now we want to state the odds of a student not passing the test. Well, we have the odds that a student passes. So the odds that a student does not pass would be, so does not pass, there's 5 ways that they don't pass, or they don't pass 5 out of the 100 times. And then it would be total minus in favor of passing. So they pass 95 times. So it would be 90. Oh. Sorry, this should be 5. Right, and this would give us 5 to 95. And again, these two should just be switched. This is the odds of passing, and this is the odds of not passing. Any questions on this example? right? So you can probably see that we can, right? So there's multiple ways that you can kind of go about doing these multiple part questions, right? So since we found the odds of passing, and then it asks the odds of not passing, we know we can just switch these. So we can go straight from here to here. But if you didn't know that, you could follow odds of not passing here. So this is what we did here. Right, so the odds against passing was total minus A. So our A is passing, so we had 5. And then 100 minus 5 would be 95. So there's multiple ways that you can kind of look at these problems. For question this next example, the odds against a smart TV being defective from a factory is 20,000 to 3. Right, so this is the odds against. Right, so again, this first number would be against and in favor. So if the company produces 64,000 TVs per month, how many would be defective in a year? So this is a different type of problem. What do we need? What kind of problem is this? So this type of problem wasn't on your AC, but we did cover it. We're given a sample, and we want to predict, right? We want to predict how many TVs would be defective in a year out of these 64,000 TVs, right? So we have this prediction formula equals the probability. We want to find how many would be defective. So it's probability of defective times the sample size, which is 64,000. So we have the sample size, we're given that, but we need the probability, right? But we can get that by these odds. Right, so this is the odds against a TV being defective. Right, so we want the odds in favor of it being defective. So the probability of it being defective, right? So in favor, how many ways can it be? How many ways can a TV be defective? Right, 3. Does everyone see how I'm why it's not 20,000? Like, are there, because this can be a little confusing. So does everyone see why it would not be 20,000? Because this is the odds against a smart TV being defective. So this is against being defective. This is not defective. We kind of have a double negative here. I think that's what it's called in English. Does everyone see that? Okay. And this would be in favor of it being defective. Right, so we have 3 over our total. What would be our total in this case? I think I heard 20,000 and 3. So we add 20,000 plus 3. So it would be 3 over 20,003. So we have our probability of defective, so now we can make our prediction. times our sample size, which is 64,000. And if we plug that into our calculator, 0.03 times 64, that gives us 9.5. 9.5. So just for, right, I did say just round to 4 decimal places. So I will do that. Right, but this is, it's asking for how many TVs would be defective. So it makes sense. We can't have 9.5 TVs, so let's just round it up to 10. 10 TVs would be expected to be defective. Yes. Sorry? 64,000 TVs per month. How many would be defective in a year? So, yes, this would change our answer. So, does anyone know what this? So we did answer something. So this would be the number of TVs defective in a month. So how would we get the number of TVs defective in a year? Exactly, yeah. So we can multiply. So yeah, thanks for pointing that out. So I'm just gonna, it's not our answer, but it does, we needed one more step. So this was the number of TVs defective in, so number of 9,000 or 9.6 TVs in 1 month, right? But we want the year. There's 12 months in a year, right? So we just take that, right? And I still have it in my calculator here, and times that by 12. And that will give us our answer. So times 12. So it's 115.1827 or 115 TVs in a year. So there's about 10 minutes left. For we're not going to start anything new. So there's this example here that we didn't do. So you can do that one on page 22. And then tomorrow we will start with determining which event is more likely to happen. So you can, so for this one, actually, there's nothing new here, right? So if we have a question, determine what an event that is more likely to happen, we just want the event that has the higher probability, right? Higher probability, higher value indicates a higher chance of it happening. right? A 95% chance is better than a 10% chance, right? So you can actually try the first example. So there's a lot of examples here. Try these first two examples on page 22, or sorry, 23. So again, there's no new concepts here. So we're given the odds, we want to state the probability, and then there's just this added question here of which is more likely to happen. And you just use the answers in A and B, which one is higher probability. So do those two, and then yeah, we'll continue on with the book, and we'll look at experimental probability versus theoretical probability. We'll get into that next tomorrow.